When you have to integrate some functions whose integrals are not immediate, you can use something known as the substitution method. Now, it's best to explain this using examples. So let's write down one example. Say I have to integrate 6x over 3x squared minus 5 dx. Now, if I had to take the derivative of this, I could apply the quotient rule. But there is no such thing for integration. The other thing I notice is if I focus on the denominator and if I want to replace that with some other letter, u equals 3x squared minus 5, then I notice that the numerator is the derivative of this denominator. So du over dx would be 6x. So that's good. And now, if I want to change this to u, so I have integral of something over u. So that's good. I try to change it to the variable u. So I can't have dx. I should be integrating with respect to u as well. So the point is, whenever you are using substitution method, you change something, you let a function be equal to u, then you also have to find du. Now notice here du over dx does not mean you're dividing du by dx. This is just a symbol. But it so happens, and we require some analysis to prove this, that if du over dx is 6x, then du would be 6x dx, as though you get the same result when you multiply both sides by dx. Now mathematically that's not what's happening, but you can remember it that way. So what happens is your integral is now 6x dx is just du, and your denominator is u. Now this is something we know how to integrate. This integrates to natural log of absolute of u plus c. And now what we want to do is we want to change this u back to x. So what is u? U was defined to be 3x squared minus 5. So that's what I'm going to write down. 3x squared minus 5 plus c. So in this example, what happened was your denominator is something and your numerator is exactly the derivative of the denominator. So that's why you had 1 over u as your new function to be integrated. Sometimes it's not exactly the same. In fact, let's modify this a little bit. Let's change this 6x to maybe 12x. So that's what I'm going to call example 2. Integral 12x over 3x squared minus 5 dx. Now there's no harm in, again, letting u be equal to 3x squared minus 5, and then du is simply the derivative, which is 6x and dx. So what I have is not exactly du, but twice of du. So if I have some constant multiple, then that should be okay. So I can write this as 2 du over u. And the constant could be pulled out of the integral, and you get 2 natural log of absolute of u plus c. So that's going to be 2 natural log of absolute of 3x squared minus 5 plus c. So that's what you can do. So here is the key. When you're using substitution method, then what you want to notice is some part of your integrand is a function and the rest of it is the derivative or some constant multiple of the derivative. So in other words, if you see a function and its derivative in the integrand, then that calls for substitution method. And that's what you can do when you have to integrate tan x and cot x. Because tan is sine over cosine and cot is cosine over sine. And you see that if you let the denominator be u, then the numerator becomes du. Yeah, your derivative should be in the numerator position for substitution method to work.